So when we simplify radicals or a square root, so hopefully you've heard of a square root. You may not have heard of it called a radical, but here is our square root symbol, and that's because there really is a little 2 here. We just don't write it. But that symbol itself, this little weird division symbol, that is actually called a radical. Perfect squares are integers whose square root is a whole number that was multiplied by itself. So when you did Pythagorean theorem in 8th grade and you had like square root of 25, you said what times itself is 25, and you got 5. So that's what we're going to actually start by looking at. We have perfect squares over here on the right. So let's fill these in because we will reference those as we go through some stuff today. So list of perfect squares. So 1 times 1 is 1, and 2 times 2 is 4, and then we have 9, 16, 25, 36, 49, 64, 81, 100. This is actually 121 and 144. So the thing you need to remember is that when we have perfect squares like this, essentially what we're doing is we are taking the square root of this number, and we would say what times itself is 1, what times itself is 4. And that's the part we're going to be looking at today. So that little chart is going to be helpful to you. What is the integer underneath the radical? Is it on our list of perfect squares? That's what we need to decide. Or if you take the square root in the calculator, is it a whole number? So your yellow calculator is going to be really nice. If the square root ends in a decimal, it is not a perfect square. So essentially, if it is not on this column over here on the right-hand side, that only goes to 12, there are more, then it is not a perfect square. So just some examples to review from 8th grade. The square root of 25 is 5, because 5 times 5 is 25. What about the square root of 49? 7. And the square root of 100? And the square root of 24. Is that actually on our list? No. We know that the square root of 24 is really close to the square root of 25. So once you use your yellow calculator, and you're going to actually type this in. So to get the square root button, you're going to hit Control and the squared button, which I believe is next to the 4, and then you'll type your 24. All right, so this is in the calculator. This is 4.89, and it keeps going on and on and on and on and on. So this is going to be not a perfect square. Writing this as a decimal is very ugly. So one of the things we're going to practice today is how do we write this without a decimal and it doesn't look so blech. So this is an imperfect square, and it's an integer whose square root is not a whole number. So for example, the square root of 10 is not a perfect square because its square root ends in a decimal. So if we put it in the calculator, we get an ugly decimal, not a perfect square. So let's talk about how to write that nicely. So we're going to look at this 2 ways. I'm going to show you in the calculator to check your work, kind of as a shortcut, but I'm going to show you this factor tree first. Now, you do need to know your times tables to do this. Usually, though, we're really looking at breaking this into what we call primes. So 2, if you were going to divide by 2, we're going to divide by 3, we're going to divide by 5, maybe 7. But really, those are our main ones that we want to break this down by. And our goal is to make these all be prime numbers, so a number that is only divisible by 1 in itself. You can do this lots of different ways. So I need you to tell me 2 numbers that multiply to make 150. And there are several different sets of numbers that multiply to make 150. You can use any of them, right? So you pick, what do we think? What multiplies to make 150? That one. 75 and 2, okay. Now, 2 is a prime number. So I'm going to leave that one alone, but 75 is not. What multiplies to make 75? Think about quarters. Can we say 3 and 25? Okay, so 3 is also a prime number. What makes 25? 5 and 5. So what we're going to do now is we're going to look at, if I put all of these prime numbers now under my radical, and we divided to get that, so we'll multiply. So we're going to say 2 times 3 times 5 times 5. Okay, now because this is a square root, there's a little invisible 2 here. That means we're looking for pairs. Well, I have a pair right here, don't I? I could rewrite this as the square root of 6, 2 times 3. What do you know about 5 times 5? Square root of 25. Is one of these a perfect square? Can I find the square root of 25? What do I get? I get 5. Can I take the square root of 6? That is not on my chart. That's not pretty. So we're just going to write 5 on the square root of 6. So here's the thing that we're going to look at on this second step. We wrote our prime factorization underneath our radical. We circled our pairs, which is 2 of the same factor. Okay? We can underline our singles. Okay? And we're going to look at this again. Our circled pairs will go outside one time, and the singles will stay inside. And if we put anything inside, we'll multiply. So before we do that, I want to show you how you can get to that 2 times 3 times 5 times 5 in your calculator. So turn that on. So in our calculator, I want you to press the menu key. We all know where that is, right underneath doc. And we're going to choose number 2, and then we're going to choose 3. And you can see on my picture it says factor parentheses. And in the parentheses, you're going to put that number that was underneath our radical on our paper. We had 150. Type in 150. You're going to hit enter. And that actually did our factor tree for us. So we had, when we did our factor tree, you can see there, 2 times 3 times 5 times 5. So we have 2 times 3. 5 squared is 5 times 5. So it actually broke it down for us. So if you want to continue to use this on our assignment today instead of doing a factor tree, that is perfectly fine. So 150 is the one we just did. It is right here. So again, circle any pairs, which we did. Underline our singles. And here's the key. You got to put that circled pair outside once, because we said this was the square root of 25, which is 5. So when we write that, okay, that's going to go on the outside one time. And then we still have our 2 times 3 inside, and 2 times 3 is 6. So if you follow these steps, you write your factors. We circled our pairs, underlined our outside ones. The singles stayed underneath, right? So think of it like this. Couples or pairs, they go outside on dates. They go out to the movies. They go out to play putt-putt. So they go outside the radical. Singles, they don't have any dates. They're kind of lonely. They stayed inside, okay? So let's try the next one. Let's go to our calculator. Let's put in menu. Remember, it's menu. 2, 3, square root, and you're just going to type 24. And then we're going to write what it tells us. So we get 2 to the power of 3. So what does that mean? That means 2 times 2 times 2. We're going to write 2 3 times. So again, circle your pairs. Underline your single. Where do the pairs go? They go out. Right? That's really 2 times 2 is 4. The square root of 4 is 2, which is why we're only writing it once. And the singles stay inside. So this is a lot nicer than that 4.89 blah, 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 blah that we got earlier when we put it in our calculator. Okay? So when we put 32 in, you get 2 to the power of 5. So we're going to write 2 5 times. 2, 2, 2, 4, and 5. And again, we're still circling our pairs. Pairs are going to go out. We have 2 of them, Remember, whenever we're doing this, we're only multiplying. And our single goes inside. So we're not quite done because we can do 2 times 2. What is 2 times 2? 4 on the square root of 2. So 98 is 2 times 7 squared. Again, it's the same pattern. 2 times 7 times 7. Circle your pair, underline your single. Pair goes outside. Here's the trick. Remember, only one time are we writing it on the square root of 2. Now, when you get to 6, it only tells you 2 times 3. Do I have any pairs here? No. So guess what? This one cannot be simplified. This one is just straight up the square root of 6. So if you have no pairs, it doesn't have any friends to go out with, it just stays inside and you can't do anything with it. 96 in the calculator is 2 to the 5th times 3. So make sure you write 5 2s. And then here's our 3. So we've got a pair and a pair. Those are going to stay inside. So 2 times 2 goes outside. Inside I have that 2 times 3. Remember, we are only multiplying when we do this. So tell me 2 times 2. And tell me 2 times 3. 6. And now we're done. It's okay to have a number outside and a number inside. And it's okay as long as you're making sure you're doing that multiplying in and out with those extra numbers. 11 is a little bit tricky. We're going to leave this 2 on the outside. And when we do 12, we get 2 squared times 3. So I'm going to, on the inside, I'm going to write 2 times 2 times 3. Now, because we have this 2 outside already, we're going to leave it outside. And then I have a pair, so that's going to go outside as well. My 3 is all alone. It stays inside. So this actually, 2 times 2, 4, square root of 3. So if you have a number outside already, it's just going to stay there. And you're going to multiply by whatever you end up pulling out. 4 is going to stay outside on this one. This is 3 times 7 to the power of 2. So 3 times 7 times 7. Remember, we already have this 4 outside. It's going to stay there. And now I have a pair of 7s. It's going to go outside as well. I have a single 3. Singles, they stay inside. And then I just need to do 4 times 7 is 28. And I bring down my square root of 3. You can check these in the calculator. You can type this in the calculator to get a decimal for 4 on the square root of 147 and 28 on the square root of 3. I'll show you that once we finish these last 2 examples, just so you can check your work. But don't get in the habit of writing it as a decimal. Just use that as a checking mechanism so that you can see how you did, because all of our answers are going to have to be in square roots. 84 is 2 to the power of 3 times 23. So now when we write this, we have to write 3 2s and a 3. I don't have any numbers already outside, so we're just going to pull out our pairs. And we know that 2 times 3 is 6. So just keep in mind, again, multiply, multiply, multiply. On this last one, I have a negative. What's the number right after the negative that we don't write? -1. So I have a -1. Do we know what the square root of 64 is? Is it on our chart on the right? What's the square root of 64? 8. What's -1 times 8? -8. So that one, we didn't have a radical. It was a perfect square, so we did not have a radical left. So when I rewrote this, I wrote it incorrectly. So let's go back to 13. On this one, when I wrote it, put that extra times there. So it's just 2 to the 3rd times 23. So this should say 2 times 2 times 2 times 23. So our pair is still 2. 2 times 23 is 46. That should be the correct answer. So to check your work, you can put in your square root and then your simplified square root. You're just going to make sure that those decimals match. Apparently number 13 is not correct. So again, I want you to see how we check that. So the importance of checking our work right here. This was our original problem. This is what we put in incorrectly, and then we checked it and we did get it correct. So our decimals matched. So make sure you are checking. It doesn't take very long to check. But again, when you do your work, I am expecting your answers to be in radical form, not in decimal form. So you can use it to check, but that's not going to give you your answer on your paper. Hopefully we are good. So on this one, we do have coloring. All of our answers are in square root form. So you need to write your answer as a radical and then as a decimal. Okay? So this is, we may or may not take this for a grade. I haven't decided yet.